Lori, I'm going to keep myself muted until it's time for me to do the questions.
Okay.
All right, and I'm letting all the public in, so just to let you know. And we're live on YouTube, so just to let you know.
Yeah, just let me know when we got everybody in.
They're coming in now.
We got everybody. So good evening, everybody. Thanks to everybody for joining us here on Zoom. My name is Rob DeBow. I'm the Public Works Director for the City of Malibu. And tonight we're going to give an update on the dewatering equipment, the operation and maintenance of the dewatering equipment for the Big Rock area. First, I want to give up a little background on kind of where we are, or where we were, and where we are now, kind of just real briefly, is back in '91 when the city incorporated, there was a new assessment district that was created. It was Malibu, it was a landsided district, 89-1. And what that was included was included all the operation and maintenance of all the dewatering equipment in Big Rock. And so we've had a few consultants doing the management of the operation and maintenance of that district. And this at the end of June, that contract was set to expire, and we were required to get new proposals and review those proposals and look for new consultants, or get the same consultants to operate and do the maintenance of this district. What we did differently with this district is I had two community members, Terry Davis and Joe Drummond, included in the selection process of the new consultant, and we did interviews, and the group, including Terry Davis and Joe Drummond, both selected a new consultant that I'm going to introduce today. It's Yeh and Associates. They have been selected, and they started all the operation and maintenance of the assessment district starting on July 1st, and they've been hitting the ground running. And I'm just going to let them kind of talk more on what they're going to do, but let me just kind of give you the format what we're going to do. We're going to have a presentation, and then after the presentation, we have some questions that were emailed to us. We'll read those questions, and then what we'll do after that is we'll have our consultants actually answer some of those questions. And then what we'll do is that I know there's some speakers that signed up tonight, and we will go through that order. We'll have everybody will have 3 minutes to ask questions, and then the consultant will then come back and answer some of those questions. And then at the end of that, if there's additional questions, or if someone has follow-up questions, or any remaining questions after that, we will ask those people to kind of ask those questions, and we'll go forward. Also want to point out that on October 12th, we will be giving another update to City Council on the same topic, and we will asking Council to give us direction on what to do forward on some of the recommendations that we're going to bring up. So that's kind of the format. And at the end, if we didn't get your questions, or the questions we didn't get it, feel free to email myself, or you can email Arthur from our department too, and we'll be happy to get those questions answered for you. So with that, I want to introduce Lori Berry. She's with Yeh and Associates, and she will give a presentation about the assessment district.
Great, thank you, Rob. Good evening, everybody. Can everyone see my screen okay? We're all set with my slides? Great. So my name is Lori Berry, and I'm a senior project manager and an engineer with geotechnical engineer with Yeh and Associates. I'm also joined today by my colleague, Nick Simon, who's a project geologist, and you see him frequently in the field taking measurements and doing the work that's associated with this project. We're here today to present you with a project update and a facility status for the Big Rock Mesa Landslide Assessment District. I know you all have a lot of questions, and I hope to answer some of those questions during this presentation. Oops. I don't want to spend a lot of time about our firm, but I did want to emphasize a couple of things. We're based out of Denver, Colorado since 1999, and we have about 160 geologists, engineers, and construction personnel, all with a lot of familiarity and experience with managing and monitoring and evaluating large-scale landslides. The key personnel are myself and Nick, and then John Duffy, who isn't with us today, is a seasoned engineering geologist that had worked on some of the largest landslides throughout California during his career at Caltrans, and he's a support to our team. Just wanted to point out some of those projects. We were working on a very large landslide instrumentation project up near Yosemite called the Ferguson landslide. We also just recently completed recommendations to mitigate the Fremont Hall landslide at Cal Poly San Luis Obispo. Our team supported some of the large landslides along the Big Sur coast following the 2017 storms. And we have a couple of other long-term projects more similar to this one with residences and landslide management. So I just wanted to start, I know a lot of you are obviously familiar with the area you live in, but I just want to give a brief summary of the history of the Big Rock Mesa Landslide District and what its purpose is. In the photo here, the landslide assessment district boundary is shown by the white outline, the larger white outline, and the orange color shows the main slide in the western extension, but altogether I'm going to call this the large main Big Rock Mesa landslide that occurred in 1983. But prior to that, development began within the Big Rock Mesa area by the end of 1947. Many houses were built. Today, I think there's 327 properties within the assessment district. And in 1983, the large 137-acre landslide moved. Now, between 1986 and 1996, there were extensive slope stability studies done by different consultants with David Evans and Bing Yen, and they came up with evaluating the landslide, the hazard, and provided a series of recommendations, one of which was including a whole series of dewatering wells and instrumentation. The city, so a lot of that instrumentation went in while this project was managed by the County of Los Angeles. And then in 1991, the city became incorporated. Then following some heavy storms in like the late 1990s, the city of Malibu adopted the current landslide assessment district 98-1. And I want to say that the purpose for doing that was to improve the stability of the mesa by lowering groundwater levels with the dewatering system. Also to monitor with slope inclinometers, monitor water levels to assess the effectiveness of the dewatering system. The assessment district also includes improvements to maintain and repair and replace those dewatering and monitoring facilities. I just want to add a good point that in the whole idea of managing this landslide is controlling water in versus water out, and the sources of water coming into the region as imported water and also from rainfall and precipitation. The ways that we dewater and get water out of the assessment district is through dewatering wells, hydroggers, natural evaporation, and also surface drainage that's correctly and properly collected and taken down into the storm drain system. And just wanted to add that now here in 2020, we are still operating and maintaining the same landslide assessment district with those same goals and purpose. So as Rob mentioned, Yeh was hired through a selection process through the city of Malibu and began our work in late June 2020 and began our work July 1st. To that end, what we do for this project is to monitor and measure the dewatering output, We measure the water levels throughout the district. We survey the slope inclinometers. We maintain and repair the equipment, and we replace equipment under our allotted budget for capital improvement projects. Now, our current equipment includes 23 dewatering wells, 37 hydroggers, 29 standpipes, and 28 inclinometer casings. And based on the work that we have performed and the data we have reviewed since we've become on board, the water levels remain lowered, the dewatering system is functioning and maintained, and there's no consistent, discernible movement in the slope from the slope inclinometers. So we have been really busy. We have done a lot of research, a lot of data review. We've been hiking through the district, collecting information, not only to wrap our heads around this project, but also to provide responsible, educated answers to your questions and to just keep maintaining and monitoring the project. So just in these last few months, we've recorded the flow from all the wells, the hydroggers, and measured the water from all the standpipes. So we've done that for 3 months in a row per our contract. So this is that every month, that's part of our scope of work, is to do that basic measuring. We also have to take water quality samples and submit them for environmental testing to comply with an LA Regional Water Quality Control Board NPDES permit, which has to do with the discharge of all the water coming out of the dewatering system and discharging it into the ocean. So that is permitted by LA County, and we have to follow strict testing protocol to be in compliance with that permit. We also performed baseline surveys on the inclinometers. We performed an inventory of the existing facilities. We've scheduled maintenance of some hydrographic conveyance lines that need some repair along the PCH. And we've completed maintenance and repairs on, I think, up to 10 different dewatering wells. And those repairs are all part of the maintenance budget of the existing assessment district and within our scope. And what we've done is we've replaced pumps in dewatering wells W2, 17, and BYA1. While those pumps were out, we've video logged W2 and W17, and we also took the opportunity to video log W3, get a better idea of what was going on there. We've installed groundwater sounding tubes at 4 different dewatering wells. We've repaired the pump controls and the electronics at 2 of them, and we've replaced flow meters at 2 of them, and we've repaired a broken discharge line that was right next to the vault at one of the dewatering wells. So all this we've completed within our scope in the last few months to get everything functioning. So now I want to go through sort of the results of our data collection and share some of the data trends that lead me to those conclusions that I've stated, and I'll state again, about the function of the system and the water levels. So first I want to talk about, again, the sources of dewatering. So this is the sources of water coming out of the Big Rock Mesa. There's 2 different sources of dewatering. One are dewatering wells, which is an active system that uses a submersible electric pump to lower and maintain the groundwater levels within an area surrounding the dewatering well. Hydroggers, on the other hand, those are the pipes you see sticking out of the bluffs along PCH. Those are a passive system. They're a horizontal drain, perforated drain that's drilled into the hillside. And so when there is water around the drain, it comes out, but there's no active pumping or anything like that. It's a passive gravity flow system. What I do want to emphasize is that because there's been trends over time that there's less water is being discharged now than there was at the beginning of the landslide assessment district, but that does not mean that the system is not working. In fact, when water levels decrease in the dewatering wells, it means there's less surface area below the less well surface below the water table. So then there's less area to recharge the well, and so there's less dewatering volume coming out of the well. So that's a perfect example of water levels decreasing in a well, and the dewatering volume will lower even though those water levels are being maintained low. Now the hydroggers behave a little bit differently than the dewatering wells. In the subsurface conditions found at the Big Rock Mesa, it appears that many of the hydroggers will have rapidly dewatered a relatively confined groundwater zone. And once they were constructed and installed into that zone, they dewatered very quickly and then had very low steady production. And in some cases, they stopped producing very quickly after they were installed. And even there's also some cases where they were installed as a secondary, one hydrogger near it was producing a lot of water. So the consultant at the time put in a second hydrogger, but because of the complex geology of the Mesa, some of the hydroggers just never produced. And that's why I wanted to show this photo. I know this has been a question. So there's a lot of hydroggers sticking in the ground, and we're monitoring all the ones that are currently flowing, in addition to some that flow just periodically when they're reactivated by rain or other changes in water. And there's some that are left in the hillside that are no longer producing. But if water levels did increase, or if there were, heavy, continued period of heavy rain, it's possible they might reactivate. And that is why we keep them there, and we take a look at them and see. And if any of them start producing more, then we'll start to take water measurements from them. And here I just wanted to show, this is a really interesting information. These are two examples of what I was talking about, where shortly after the hydrogger was installed, the production of water coming from it diminished very, very quickly. This is H4, which is a hydrogger that we still monitor. And you can see it was installed in 1984, in June of 1984 by D.A. Evans. And at the time it was installed, it was pumping, actually at the very beginning, it was even higher, but it was about 14 gallons per minute. Within a short 6 months, so already here by December 1984, 6 months later, it had decreased in production down to 1 gallon per minute, and steadily stayed that way for the next year. And that's still how it produces right now, is just stays. So again, it was installed, a very quick decrease, and a lot of water coming out of a confined area. And then now it's just steadily kind of in a low flow condition. I just want to show one more example of that. This is another one we still monitor, HD3. Again, very high, 80 gallons per minute when it was installed in 1984. By December, less than 6 months later, just a few months later, it was down to 20. And now this one kind of shows an example of how some of the hydroggers are reactivated in response to rain. So these little bumps are likely in response to different rainstorms. It goes up and down, hit a low spot of 5 gallons per minute. And this one also just stays low, like most of the hydroggers are relatively low flowing. Another set of data that we look at is the trends in the groundwater levels. In fact, reviewing the groundwater level data along with the results of the slope inclinometers is really our best tool right now for assessing how the system is functioning and where and how we should improve or repair things. So this table is just a summary of some of the dewatering wells and standpipes. I took kind of a scatter, I guess, across the district, and selected just several kind of within each subslide area, and just wanted to make a point to show that water levels when these were installed in the 1980s were very high, and they've continued to lower, and they're still lowered water levels. So just as an example, in 1983, well number W1 was installed, and the first earliest reading we have from 1983, it was a depth of 63 feet below the ground surface. And now we measured it just last week is 125 feet, and that's consistent across the board. With many of these facilities, you can see that they've decreased from their original water level at install to current water level. Some of them over 100 feet, 150 feet. And I also wanted to add that we took the time last week to take these water level measurements with the pumps turned off. And by doing that, we wanted to see if there was much influence of the water levels with any nearby pumps. And what we found was that we had readings from September for our monthly reading and compared them, and they're very similar. So in general, we do not that we don't see a significant difference with the well pumps turned off, and that these numbers do represent a condition with those off. Now here we're going to start talking about, so I just kind of talked about the two sources going out of the Mesa, the dewatering and the water level, or the two types of dewatering, and how we evaluate those by looking at the water levels. Here's another summary of one of the inputs to the system. This is rainfall. So here's a plot of rainfall dating all the way back to 1968 to 2020. And you can see, despite us having kind of the last couple of years here, we've had some higher rainfall. You can see right through here, we've been in drought. And you can see that really clearly, periods of drought and periods of high water. But despite our higher water over the last couple of years, we're still, our water levels remain low, and it might take several years to start seeing changes in the dewatering production. It might take several consecutive years of high rainfall before we start seeing an increase in the dewatering discharge from rainfall. Another data set to consider of water coming into the district is water usage. And this is the largest source of water that's entering the Big Rock Mesa. What we do is on a monthly basis, we measure the master water meter for the Big Rock Mesa. It's been monitored monthly since 1984. And so this blue kind of squiggly line are those monthly readings of how much water was consumed by the Big Rock Mesa Landslide Assessment District. Now the black line is what we'd call an average trend line to kind of better see those different trends and see the pattern of water consumption. And finally, the dashed black line, the horizontal dashed black line, is a true average of all of this data of water consumption through the last 35 years. I want to point out here that here we are today at the end of 2019. Our water usage here is not only below this average, we've been trending down since about 2014. And if you just follow this across horizontally, you can see that our numbers of water consumption right now are very similar to what the values were back in 1984. There's a concern about an overall increase in water consumption, but this graph shows all of the water coming into the Landslide Assessment District. And as you can see, it has been decreasing, and it is very similar to the consumption at the beginning of when these facilities were installed. And I want to emphasize that this is a good thing, this decrease, and this has to do with all of you guys, water conservation, reducing your irrigation, all of those help to minimize the amount of water entering into the Big Rock Mesa ground. So I've talked about the sources of water coming in, rainfall and water usage. I've talked about the water going out, the dewatering volume from the wells and hydroggers. We look at water levels, we look at slope inclinometers. And these are the main indicators to help us monitor and assess the function and capability of the dewatering system. Relative to our scope of work, I want to make the following points in response to the reports and letters that were prepared by one of your local residents. The project dewatering wells and hydroggers are functioning. 23 out of 23 dewatering wells are working and functioning as expected. There's 34 out of 37 hydroggers have consistent flow or seasonal flow. And we still have 4 that we're just kind of keeping our eye on. Again, going back to my example of how some of them have stopped production years ago, but we just keep our eyes on them. And we continue to monitor these. The groundwater level measurements in the standpipes and within the dewatering wells where we're able to get a water measurement indicate that the 2020 groundwater levels are well below the 1980 water levels before the slide activated and are near below the 1991 water levels once the initial dewatering systems were in and running. Lowered dewatering production combined with the lowered groundwater levels tells us the dewatering system is functioning. In the 2019 water usage is very similar to the water usage from 1984. And the slope inclinometer data does not reveal a consistent pattern of discernible shear movement. So our next steps that we will be implementing within our existing scope of work and budget are to continue our monthly monitoring as needed maintenance, especially with the winter and rainy season coming up. We'll be keeping a close eye on any potential issues or repairs that are needed and address them and get them done as soon as possible. We will maintain compliance testing and reporting for the LA Regional Board permit. We want to install pressure transducers in 6 locations. This is going to come out of our CIP, our existing capital improvements budget. We want to do this so that we can continually monitor the groundwater levels through this next rain season. And it's also going to help us to assist in interpreting if some of the readings that we're measuring are from a wet casing or an actual water level. In the past, by just using a water level sounder, there's opportunity to get some erroneous readings, but there's several wells that are kind of sometimes difficult to get those good readings at. And so those are the locations we want to put these pressure transducers so that we can get a real true groundwater level and a continuous level. We'll be able to see changes in the from rain events and how the water levels react to those, and also the dewatering pumps, how they react to that. We want to replace the electrical equipment box at dewatering well BYA1. It is rusted and almost dangerous, and it's part of a kind of a future capital improvement that I'll go over later. And then we will plan and schedule our hydrogger clean out cycle, which is just a maintenance item that is supposed to occur every few years, where we essentially jet clean out the hydroggers and try to get some of that calcification and scale that builds up on them so that they have more opportunity to produce water. So where we go from here, you know, that's all fine and good, but it's still kind of difficult to assess where and when and how to do the improvements. So what we did to help us was develop kind of a basic rating procedure to identify where we want to make our next improvements. And we've assigned a sort of functionality status to the different wells and hydroggers. And so I'm just going to quickly go through this. I'm not going to go in a lot of detail, and we can go over it more in questions. I've tried to switch over to a Google Earth screen. And here I have the outline. You can see our aerial view of the Big Rock Mesa. The white outline, again, is the assessment district boundary. The sort of orangish line is the extent of the 1983 slide maps. And here are the 23 dewatering wells. They are color-coded from green, yellow, and red. As you'll notice, there are no red because they're all functioning. Most of them are green. I'm going to first point out the yellow one. BYA15 is a dewatering well in the Western Extension that was installed in 2002, and it's yellow because it historically hasn't produced much water, yet it was originally installed because of some concerns of water levels rising in this general area. Data shows that this area still has water levels that are lowered, but we feel that, and the pump is currently working in this dewatering well. It's just that the water level is below the dewatering well. And then also monitoring well BYA1 and dewatering well W3 here are kind of in a checker green yellow. And we did that because they are functioning. They have pumps that are running and they work, but they are flagged for some improvement. Both of these wells, based on our data, it could be replaced with deeper wells so that we could dewater even further. Right now, BYA1 is pumping regular. W3 hasn't had much production recently, but we have confirmed that the water level is right at or just below the pump intake. Similarly, I just wanted to, we did the same thing with the hydroggers, kind of noting them as green, yellow, and red. So you can see the kind of the red ones are the 4 that really haven't produced in a long time. We're keeping our eye on. Some are green, produce really well, really consistently, and the green yellow are ones that are kind of first in line for getting a hydrog or to getting a clean out because they produce sort of periodically or intermittently, and maybe that can help improve them. And I just want to point out with this whole interface is we're working on a kind of a GIS interface where eventually we're just kind of getting started, but I hope that I can send you guys like a KMZ type file from Google Earth, and you might be able to just click on these different points, and you'll get some of the basic information, the recent water levels and such like that we're trying to implement along with our other program. So I'm going to go back to my slideshow. I'm going to kind of go through a few facts about our 10-year capital improvement plan. Some facts about our existing capital improvement plan is we currently have about $100,000 a year set aside for hydrograph clean out, a major rehabilitation or replacement of a dewatering well, hydrogger, or inclinometer. The costs of doing these types of repairs has skyrocketed, and you cannot do nearly as much as you could do back in 1990, or like even before that 1980s, when a lot of these original facilities were installed. Based on the current pricing, we can really only do about 1 to 3 improvements, 1 to 3 major improvements. We can do 1 improvement like every 1 to 3 years based on this $100,000 budget. And because of that, it's kind of difficult to prioritize, because our we have a list of things and we have to kind of take turns. If something costs more than $100,000, we may have to wait a year in order to do it, to procure enough funding in the budget to do a more expensive task. But that means we're not being very proactive about some of the things going on. So for our current fiscal year 2021 budget, which we're in right now for capital improvements, we have set aside, we wanted to replace the pump in dewatering well BYA1. That was about $11,000, and we completed that actually just last week. We want to replace the electrical box for BYA1, and we also want to install those 6 pressure transducers that I talked about to continuously monitor the water levels over the winter season. And we want to start the hydrogger flushing for some of to see if that'll start. And then the bigger capital improvements that, so that was just this year ahead. Now, this is where I was getting into, we only have 100,000 a year. We think that the next priorities within our current structure and scope and budget of the assessment district is to deepen dewatering well BYA1. We want to install 3 new hydroggers along a PCH. We want to deepen deepen dewatering well BYA15 in the western extension. We also want to replace dewatering well W3. And we want to continue to kind of rotate through the hydroggers. We can't flush all the hydroggers in 1 year, but we would go through and we can do, a group. There's 30 some of them. We can maybe 5 to 7 a year is kind of what we have planned. So the cost to maintain the district is growing, and we can't do what we could do 20 or 30 years ago with the same budgets. We recognize as much as the system is functioning, it's working, the dewatering levels the groundwater levels are maintained lowered, but we do recognize there's room for improvement to enhance the system, to implement a better monitoring system, and to also implement newer and state-of-the-art landslide technologies. I'm just going to go through each option and provide the benefits for adding funds for the assessment district budget. So I kind of listed, these are listed sort of in order, where A is essentially we feel is needed. It's a recommended approach. B, C are very important, and we would like very much to implement them. We think they would be a huge asset to the assessment district. And then as we go down into C, D, E, start getting into improvements that would be really nice. They might reduce some labor, they might introduce some remote capabilities, but they're not necessarily required to maintain the system, and then go from there. So I'm just going to go through each of these one by one and just share the benefits. So our sort of tier A for recommended improvements is to increase the funding of the assessment district for just to increase the capital improvement funding to $200,000 a year. We want to increase funding for the water quality testing, which I didn't mention, but that's another cost that is only increasing the count of testing and the amount of testing that the permit requires us to do is very costly. And then we want to increase the funding to create a reserve fund for additional for an additional 100,000 a year. Now, the benefits of doing this is it'll provide an adequate amount of funding for us to perform at least a couple capital improvements each year to improve the water quality testing and to have a reserve during emergency situations. Our Tier B includes an increased scope of work to introduce a newer technology called INSAR, which is using Sentinel satellite data to monitor ground surface movement. This is being used all over the country and the world for monitoring ground surface movement and is very common and recommended to be done in conjunction with the inclinometers, which measure movement at that particular location at depth. But this will start, this provides a capability for us to gather thousands and thousands of data points throughout the district, and with millimeter accuracy, see changes in the ground movement, which will aid us to recognize potential trends if something is starting to shift. And it will help us to prioritize the locations where we want to do improvements, and can provide an early warning. If we do start seeing a trend, we can react, we can go check it out, we can install where we need to. It's actually quite a reasonable, we can get the last 5 years of data from 1995 to 2020 and the next 12 months of data for $18,000. And this includes essentially a full survey of thousands of data points of the Big Rock Mesa every 12 days. So we would be able to get regular updates and see if there's starting to be changes in the ground surface. Our Tier C includes a scope of work to repair the surface drainage and the plastic slope and bench up in the headscarp region of the Mesa. Right now, we feel that it is a very important thing to not allow a lot of water to enter the headscarp, and laying the plastic and getting it protected, especially in years of very heavy rain, it could be very beneficial to the overall project. However, this improvement would require additional easements from private property owners, as well as annual maintenance that would need to take place. So that is a hurdle. The next Tier D is kind of introducing some new technologies to get things a little more modern, as well as introduce some remote monitoring applications. We would replace the dewatering pumps with pumps that have a dedicated pressure transducer. So this would allow us to take continuous water level data in the wells. And by doing that, and it's kind of what we're going to do this winter with those individual ones, but these would be dedicated to the well and it would continuously monitor. So then we can refine the pump controls based on the changes in the dewatering levels and volume, and to get maximum efficiency. And the other thing is to install digital flow meters on the dewatering wells, and those can be individually connected to a little cellular device and ping back, so that we really can just either monitor it remotely, or we can pick it up like with Bluetooth and get that data really quickly, and it just will assist in making the data more accessible, quicker to see changes, or concerning if a meter stops running or something, we would see that very quickly. The Tier E is an increase the scope of work to include permanent slope inclinometers with some sort of water level pressure transducer or vibrating wire piezometer in them. We could also upgrade even more to install a remote transmitter on those permanent slope inclinometers, so we would record, and again, we'd be able to view the data remotely, and it would be a web-based system. This is a very expensive endeavor, but it would greatly reduce the labor hours associated with the manual survey of the inclinometers. It would provide frequent measurements and early warning of movement, and it would be installed with vibrating wire piezometers or some kind of pressure transducer, so that we could measure the water levels continuously, in addition to where we do or do not see any changes in the slope inclinometer. F is to complete our entire proposed 10-year capital improvement plan right away. So that included, if you recall, the 3 hydroaugers, replacing 3 wells, and I think there might have been one more thing. But the benefit of doing this is getting this money up front is because we don't want to have to pick and choose which one goes first, which one goes next. And really over the next 10 years, it could kind of change. And so it's sort of moving parts. So it's a recommendation to put it all in now. It's a one-time cost, and this will just accelerate the installation of these important improvements and get them in now, and then our monitoring would continue with these upgrades. And then finally, one of the recommendations is to increase the scope of work to include slope stability modeling and analysis of the Big Rock Mesa landslide complex. To be perfectly honest, the labor and the results to do that effort, if anyone's reviewed the reports from David Evans, Yeh and Associates, these are highly, highly complex projects, extensive amounts of labor. If a new consultant would come in, we would need to very thoroughly review all the information, tweak models if we felt to. But really, at the end of the day, the benefit, getting these numbers or getting factors of safety or looking at the slope stability analysis isn't really going to point us to the right direction of how to improve and maintain the Big Rock Mesa dewatering district. And so just want to say that the benefit is a little less for this case. Oops, I'm so sorry. And I was doing so well. So I wanted to say that I hope I provided you with some peace of mind. The system is functioning, the water levels are lowered, and the landslide assessment district facilities are doing their job. But they are old, and replacements are recommended. But we want to make sure that we can put them in the right place and that we implement newer technologies so that we can the district in the most efficient and best way to bring it up to the latest technology and the best monitoring that we can do to provide safety to all of you. And with that, I believe the city has is going to get through some questions. And that is all I have for the formal presentation.
Thanks. A couple of things that now to just to let everybody know that the recommendations that Lori was mentioning, the A through G, is that what it is? I think A through
F.
Those will be extra work, or G, and that will require us to basically redo the assessment district and go out to vote and do that whole process so we can increase the funds to do so. These are the recommendations that has come up with after looking at all the data equipment. October 12th, that we are going to be introducing this for this presentation and providing this recommendations to council to give them to have them give us the direction on what to do moving forward. There could be some other recommendations coming out of those questions and provide that information to council so they can give us direction on what to do forward. So just want to make that point. And I know first what we'll do is that we've received some written questions and and then after she reads the questions, Lori, myself, and I think Nick is on here too. We'll be answering those questions. But just want to point out that the questions, if there's any questions related that are not related to the assessment district and the dewatering and everything too, is we're gonna only be answering those questions because those are related to what we're the presentation and the information we're going to talk about today. So with that, Brandy, do you want the first one?
Yes, I'm ready.
Go ahead.
The first question that was submitted is, what effect does the state of the dewatering swells that are deteriorated and full of rocks, boulders, and brush have on the stability of Big Rock?
Or you got to unmute.
Yeah, sorry. Okay, can you hear me? There we go. So yeah, the concrete drainage swales. I'm sorry, I don't want. Apologize. The concrete drainage. Sorry, I touched on the concrete drainage swales, and they are part of our recommended improvements. But currently, the concrete drainage swales and plastic protection within the headscarp region are not part of the existing landslide assessment district scope of work and facilities. Water entering that land area during periods of heavy rainfall is not favorable to the stability of the landslide. However, I will say we are a little less concerned about the rocks and boulders and debris, and are more concerned about repairing the plastic sheeting on the slopes and terrace benches. If it would be very advantageous to reduce the amount of precipitation entering the headscarp. And as I mentioned, it is part of our recommendations for improvements with a readjusted assessment district.
Next question. How many wells and hydroggers were not functioning at high levels when you inspected them? Are they now fixed and running at their full capacity potential?
Well, I want to first say that as soon as, just like a car coming off a car lot, a brand new car coming off a car lot, a dewatering well or a hydrogger, any of this equipment, the second it hits the ground, is not at its full capacity potential. There are so many variables with these types of facilities. But what I do want to point out are all the wells and the hydroggers are currently functioning. The production rates for the wells and hydroggers are typical for the last many, many years. Dewatering wells like W3 and BY15 are not showing a lot of production, but that is because the water level is near, the water level in those dewatering wells has decreased to a point where it is near or below the pump intake depth. The equipment, though, is confirmed is in working order, and it would resume to produce if water levels were to rise above the pump intake depths. Nick, is there anything you'd like to add to respond to that question?
No, I agree with all that.
Great. Okay.
You use the inclinometer data to gauge if we are dewatering enough to keep us stable. There are a number of inclinometers in low permeable areas that likely have masked readings being located so close to dewatering wells. This is mentioned in the 1992 Bingen Monitoring Report. How can we get an accurate reading of the stability and the effectiveness of dewatering of Big Rock from your company?
So I want to first kind of improve some of the semantics here, the inclinometer data. So we're assuming that the question is referring to the groundwater levels measured within the inclinometer casings. So at our site, the inclinometer casings are perforated, so they actually stand as both the inclinometer casing and they're used as standpipes to measure water levels. So dewatering wells can create a depressed water level, what's called a cone of depression, around the well during active pumping and for some time after. But the radius and the depth and the duration of that cone of depression is dependent on the pumping rate, the permeability of the materials around the well, and other factors. In general, though, the higher the permeability, the larger the radius is influenced. I believe in the question, you talk about low permeability. So low permeability area would actually have a pretty small cone and range of influence. So one way that we can verify this is we can turn off the wells and for a period of time and measure the water, and then further, once we that's another reason why we want to install those continuous groundwater data loggers, so that we can get a true good reading on and while the pumps are on and off, and through that whole process. But Yeh performed water level measurements. We checked for changes in the water levels of selected standpipes and within the wells where possible, with both when things were operating as normal with all the pumps running in our September reading. And then we also went back and we measured the water levels in those wells a few days later with the wells after they had been shut off for at least 24 hours. And what we found was like the two standpipes, SP16 and 16A, located near dewatering well BYA1. We know that they are likely influenced. Those two standpipes do see an influence in dewatering changes in BYA1. This is known, and we're aware of it, but we can always have the ability to measure the water level directly in the well with the transducer. Standpipe SP9A, which is located near well W13 and well BY4, we didn't measure any change pre and post having the pump turned off. In standpipe SP3A, which is located near dewatering well BYA 5, 6, and 12, those were all turned off. We measured the standpipe and the wells both before and after, and did not see a major change. Standpipe 21, which is located near dewatering well BYA2, did not measure any change did not measure much change in water level between July and September of 2018. And during that whole time, BYA2 was actually shut down due to a malfunction based on the data in the annual reports. Standpipe SP20, which is located near dewatering well 15, has not been influenced by BYA 15 due to the low production that's in BYA 15. The remaining standpipes and inclinometers, so what we did was I should back up, the ones that we did that double check on are all the ones where there were standpipes relatively close to dewatering wells, but what we concluded was that most of them are not influenced by the nearby wells. The only one that we do feel definitely is BYA A1, and the remaining standpipes and inclinometers are not near enough to the dewatering wells to be impacted by this cone of depression. And we do have other means of monitoring those water levels as well to confirm that. Nick, is there anything you'd like to add to that one?
Nope, that's exactly what we did.
Okay.
There are a number of sites with ponding water in the assessment district. One large puddle is located on Inland Lane, halfway down on the right-hand side of the street, across from well BYA 13. And it's been reported by residents in the county that septic is leaking here. Have you studied this? What were your results if so? Where is this coming from? Why won't it drain? And is this expected to go out to the ocean via the storm drains?
So Lori, do you want me to answer that one, or?
Yeah, I believe so. Yeah, it's kind of out of our scope of work too.
Yeah, so this item is not included in their scope of work. If it's something that the community wants to add to their scope of work, we can make that recommendation to council and add this in, but that's just something that we just need to know through the whole community, if that's something that consultant wants to, or that the community wants to add. So.
Next question. Have you inspected cracks and rock fall in the immediate area? How do they affect the stability of big rock?
So, yeah, at the informal request of one of the residents, Nick actually walked several of the locations that were, there's a crack map that's included in the Binyan 1992 report, and he kind of walked it briefly and at the informal request of this resident. But based on these limited observations, there really isn't enough sufficient evidence to determine if the existing cracks are currently active or if they're related to activity. However, watching the cracks is a way to see if things start to mobilize, and the satellite data that we were talking about would be one very powerful way to see those crack trends. But right now we're not seeing anything definitive that would indicate additional cracking one way or the other. Rockfall is a common occurrence along the coastal slopes of the Malibu area, and it occurs all along the California coast and inside the Big Rock Mesa area. The slopes that are formed by the rock materials within the Big Rock are prone to rockfall just by them being jointed and fractured over the years. But the rockfall does not play a direct role, nor is it an indicator for stability of the Big Rock Mesa landslide. The primary concern with rockfall relative to Big Rock Mesa is its potential to damage the facilities. And I think there was another question at some point about the cages. You can see those along PCH, some cages sort of protecting the facilities. Those are so that the rocks, if they do come down and roll down the hill, aren't going to damage or break off the hydro augers. And it also protects us when we're down there manually reading those. But they do not, but rockfall does not impact the stability.
So the next question we have is, water usage is 24% higher than 20 years ago, yet we are not dewatering as much as we did back then. How can the system be working efficiently if this is the case? Also, rainfall increased from an average of 15.88 inches per year to 22.24 inches per year during the latest monitoring period.
Yeah, so I went through the historic rainfall data as well as the historic water usage data, and I'm not certain where the 24% is exactly coming from, but what I do want to respond with is regard to water usage is based on the monthly readings from the Big Rock Mesa master water meter. There's an average of 141,000 gallons per day that was imported during the 2019-20 monitoring year, which is a decrease of 3.3% from the previous 18-19 monitoring year. And then again, during the 18-19 monitoring year, there was a total of almost 146,000 gallons per day was imported. And that was a decrease from a decrease of 6.7 from the previous monitoring year. We're continuing to see a downward trend. As can be seen by the summary graph that I shared previously of the water usage back to 1984, the water usage varies seasonally, and the usage peaked in the early 2000s and again in 2014. Water usage has declined since the 2000s, the late 2000s, and is below average. And is below the average when calculated for the whole period between 1984 and 2019. And similarly, the current water usage right now is very similar to the amount that was recorded in 1984. With regard to rainfall, the rainfall total of 22.4 inches that's provided in the question was from the 2018-19 rainfall season, which was 2 years ago. It should be noted that although the 18-19 was a wetter than normal year, 6 of the 7 years prior to that had significantly below normal rainfall. The total rainfall for the 2019-20 rainfall year was recorded to be 16.61 inches. The 19-20 rainfall total is 7.8% higher than the 49-year average, which was 15.4. So the whole average from 1984 to now is 15.4 for the whole area, but it is that's for the Big Rock Mesa area, but it's only 1% higher than the 16-year average from the LA Department of Water and Power rain gauge. That's 1239. So there's a rain gauge that started to be measured. It was installed in the 90s, I believe, and yeah, actually Bing Yen in 1992 cites an amount of 16 inches of rainfall as a regional historic rainfall average that they used to calculate the water budget for their studies and analysis. So there's a master rain gauge that's referred to in the annual reports that covers an area larger than just the Big Rock Mesa. And then there's also a rain gauge that we don't have quite as many years of data for, which is 1239, that's specific for the Mesa. And that average is a little higher, which just shows that we're really not, we're still right in the range of those average years right now and coming out of a severe drought.
Okay, the next question we have is, do you believe there should be continuous development adding water into the ground in a fragile landslide area? What strain does that put on the dewatering equipment? There have been over 100,000 square feet of additions and new building since the system was upgraded in 1992, with over 35 new on-site water treatment systems and 18 pools and spas that can leak and overflow into the ground.
So I want to stress again that this question could be raised at the city council level. We're just giving an update on the current system and the recommendations that we're going through.
Next question we have, if we keep adding bathrooms on septic, what will happen to this hill?
Same question, and at the council level, we'll have somebody to respond to development questions. But this is a meeting we're talking about for specifically for the equipment and the operation and maintenance of the system.
Next question we have is, should there be greater study of lots that want to build or expand in Big Rock than in other places in Malibu?
Once again, same comment.
And the next question we have, our well on Pier da Chica Road used to regularly pump out over the years on average 500 gallons per day, and now does maybe 10% of this, if at all, over the last year. I've been told it's because the water level doesn't reach the pump, but how can that be even in the very rainy seasons given the historical data? Could there be something actually wrong with the well? Frugro has mentioned in their spring quarterly report something about the well casing possibly being defective.
So the well in question is the dewatering well W3 on Pedro Chica. And this well, the pump system was replaced under the last consultant last year. But we knew there was a lot of concern, and we wanted, and when they replaced the pump, actually, they removed the ability, the airline, which we weren't able to get a water level out of the well. So we went back and when we came on board and we wanted to video log this well, we did that in September, just last month. And in the video log, it is definitively clear that the groundwater level is at or near a depth of 160 feet or a little bit lower. And that's the depth that the pump is, so that is about at or just below the pump intake. W3, if you recall, is one of the wells on our 10-year capital improvement plan to replace with a deeper well. It does appear that there could be a benefit, and we could get more water out of the Mesa by deepening a well in that area.
Another question that we had submitted is, this is one photo I took at the bottom of PCH. What state are the hydroggers in down there? And what is this duct taped broken pipe doing holding up this other pipe?
I think I'll let Nick answer this question.
Okay. Well, I saw the picture. The picture of this is of a hydrogger HD43. The broken pipe is holding up the conveyance line. That hydrogger is functioning just fine. It looks like, based on the annual report, last year Fugro had some damage to that conveyance line from some Caltrans activity, and it looks like it knocked a support that was suspending that conveyance line as it has to span its way over to the storm drain. At some point, somebody just wedged that pipe they found there because it was the perfect length and they never got back to it. It's on our list. I want to get us these certain things. It's a steel spike with a cradle at the top to suspend that. But it's not a super high priority repair because the hydrogger is functioning perfectly. And in the short term, that repair is just cosmetic.
So I also want to bring into is that, yeah, it's on our list for them to fix that and going through, but there was some logistics that we had to work out between the city, Caltrans, that is on Caltrans right away. That requires an additional encroachment permit. The city has one, but it was in with Burgro's name, and so it took a little bit and back and forth with Caltrans to actually get Yeh and Associates covered under Caltrans. I think we just recently just got that permit, and so now they're actually able to go out there and do that work. Next question, Randy?
There's more, yes. Both our geologists have stated that if the toe of the slide is exposed on the seafloor, then salt water encroachment further into the slide mass will occur with sea level rise. In addition, the location of the Malibu Coast Fault near the shoreline may be acting as a buttress to the basal part of the slide, but any seismic event that would occur along this fault could stimulate failures. However, the conclusion in the report that reducing friction at the base of the slide mass by establishing dewatering wells along PCH should prevent movement regardless of the geometry is correct. It appears that installation of dewatering wells along PCH near the toe of the slide is needed to control the influx of water, whether from land or sea. Do you have plans for this?
Yeah, so I want to start just saying that an evaluation of the stability and of the landslide, in addition to evaluating the seismicity of potential faults and seismic sources near Big Rock Mesa, including those from the Malibu Coast Fault, is not part of the assessment district scope of work. And further, Bing Yen did do an extensive portion of their 1992 report. Essentially did this analysis and looked at nearby faults and their potential impacts. And on top of that, the current water levels that are recorded in the standpipes along PCH in just this last month and in the recent months indicate that the water levels are below both the 1983 and the 1990 water levels presented in Bing Yen 1992. It's also complex. In order to design a dewatering system with dewatering wells along that portion of PCH where you're essentially at sea level would require a full hydrogeologic evaluation that would need to be done to assess the feasibility, the practicality of using dewatering wells at that point, and their capacity and the capacity to even lower them. It's very likely that it would have to be a very complex continuous well system, not just these individual dewatering wells. And then I just want to comment that sea level rise is really just a broad phenomenon that all of the coastal cities, including Malibu, is needing to address. And the effects of sea level rise is outside of the scope of work for maintaining the landslide assessment district today.
Okay, the next question. There's a handful left, Lori. Do you believe there should be more development here which would increase groundwater in this fragile landslide area?
Once again, that's outside of our scope to comment on that. And in regards to development, we're here to answer questions about the current dewatering system and what we need to do to move forward.
On to the next question. How would you quantify the additional strain of the dewatering equipment from new development? What additional maintenance and replacement costs would there be for residents as a result of new development?
So same question.
Thank you. There have been over 100,000 square feet new builds and additions since the system was upgraded in 1992, with over 35 new on-site wastewater treatment systems and 18 pools and spas that may leak and overflow into the ground. How has this new development and related water usage affected the slide?
That's a question that can be brought up during council. At this time, this is not a question related to the current dewatering system and operation and maintenance of it.
Thank you. Next question. Should there be more in-depth studies done on proposed development in the Big Rock area that in other places in Malibu?
That's a question for our building and safety and our geologists question. They're not here right now because we are talking about the current dewatering system and that operation of thereof.
Does the city or contractor Yeh and Associates plan to do basic periodic maintenance of all of the drainage features included in the original assessment district, including swells and drain pipes? For example, running down across my property is a 2-inch diameter drain pipe that has not been examined by anyone since it was installed circa 1990. It runs down from somewhere near Cool Oak Way past 20544 Seaboard to MRCA's so-called Pocket Beach. This presence impedes discretionary brush clearance, which the city should be doing within 5 to 10 feet of the pipe for maintenance purposes anyway. If this pipe is not to be maintained, the least the city could do is to remove it for lack of legal easement. It's in a natural canyon drainage, so most of the flow reaches the beach anyway. Or looked at another way, since the city hasn't paid fair market value for an easement, nor did the county prior, maybe the least you could do would be keep the brush cleared around the pipe. This notion does not necessarily constitute an implied waiver of full value of an easement.
So I think I know who this came from. It came from Craig Hill. I think
Yes,
it's
sir.
Craig. Maybe we could meet offline and we can talk about it and kind of see where on that pipe. I did some research earlier when this first came up too, and I couldn't find anything. So maybe we just need to get together and somehow figure out what we can do to move forward with that, and get some answers for you for that one.
This concludes all the written questions that we received prior to this meeting.
Do we have any speakers?
We do have 9 speakers.
So we're going to go in order. Each speaker will have up to 3 minutes to ask their question, and then myself and Nick will be able to provide a response after you finish your questions. And then once we go around with the speakers, if there's anybody else that has any additional comments or questions, there's a function at the bottom. You can raise your hand, and then we can go in order and get some people's questions. We do have this until what time, Brandy?
Till 8 o'clock.
Till 8 o'clock. So with that, let's go to the speakers.
So our first speaker is Joe Drummond. Joe, are you there?
Yes, I'm here.
Okay, I'm gonna hit start. Go ahead.
Okay, Lori, you said that it would cost $300,000 to $400,000 to do a slope stability monitoring, or I mean, we had 2 geologists look at the, there are existing LiDAR light scan procedures, and apparently there's a DEM, digital elevation model, that can be completed reasonably, like $3,000 to $4,000 for the assessment district with drones or aerial photographs to develop a base map and then annually check the elevation levels for about $1,000 to $2,500. So that's a far cry from $300,000 to $400,000. So that's my first question. So I don't know why a new assessment district would be necessary to do that. Also, you confirmed that the cracks in the pavement could possibly be related to the landslide, but you haven't done enough. I mean, is that not in your scope to, if that was added to the scope, could that give us more of a gauge of where we are at in our stability? And then, what else? Oh, and how long did you turn off the pumps for those wells that you did recently check the groundwater levels that were possibly masked by the coning effect? That's what I wanted to know.
Shall I respond now, or is
Is that it, Joe?
I mean, I have some more. I also, when you said that the hydroggers are protected by the damaged cages affected by bluff failure, how are these failures measured in the slope stability of Big Rock? I mean, how can the rockfall not be a gauge of slope stability? Especially when in the past in Big Yen's reports, it said that they were called bluff failures, not rockfall. And then if we don't have enough money in the assessment district, how can we maintain our stability over the next few years? That's what the big question is. That's all for now.
okay? I'm going to start with the shorter ones. How long were the pumps turned off when we did the recent comparison of the water levels? They were off for a minimum of 24 hours, but there were a couple of locations where we had data going back, historical data where pumps were down for a few months, and could look at some historical data, concluded that very few of them appear to be within the cone of the influence of the dewatering well. And again, in the areas that may have some unique groundwater level readings or inconsistent readings over time, we are proposing to put in continuous data groundwater level loggers over this next rainy season to get a better, to confirm that information, or to just get a better handle on how the water levels are reacting to changes in the dewatering and rain events. And other sources of water. With regard to the cracks, cracks, new cracks with an open, fresh surface can be indicative, but it's not within our scope to walk the entire mesa to look for cracks. Like I said, we had kind of decided to walk the crack map from 1992, and in areas that had been recently paved, there were no obvious new cracks that were blatantly obvious as being fresh, and there were some existing cracks in some of the older pavements that were filled with gouge and had been slurried over, and there was some vegetation growing and stones and things, and generally we don't have enough information to tell if those are indicative of recent movement, because we don't have data from the last several years to see how they've changed. And that kind of brings me into your first part of the question, was talking about the price to do a slope stability analysis. Now, doing a slope stability analysis is not the same thing as doing continued survey monitoring of an area. Those are two very different things. Slope stability analysis is a sort of an academic, technical exercise where you are evaluating all of the subsurface boring logs, all of the groundwater data. You're collecting shear strength data, classification data. You're studying the geologic dip and slope of the formation and which direction and how fractured and how jointed these different formations are. And that work was done very thoroughly by Yeh and Associates. And based on the water levels now compared to the water levels and conditions in their report, it's our opinion that the Mesa is in about the same condition as it was during that time. And regarding the drones and the DEM you're referring to is sort of a LiDAR-based monitoring system. Now that is a technology that can be used for monitoring slope movement, but the problem is for the kind of cost you're talking about, and I've talked to several experts on this, you cannot get the type of accuracy and from a standard LiDAR. The drones would need to be a very high-end drone that has GPS directly on it to get the kind of accuracy on the ground. And even when you did that, let's just say instead of 4,000 or 5,000, like you said, it's on the upwards of say 10,000 to do an annual survey. That's just one survey. And then next year, that's one more survey. We're overlaying just two surveys, and it may not tell very much. That's why we're proposing and recommending the satellite data, which is something that will allow us to collect that ground surface data to millimeter accuracy. And the satellites are already orbiting every single day. So it essentially, we work through a company who obtains the satellite data directly from whatever space group or company, and they process it. And so we can see millimeter changes from 12 days at a time. And we find that to be extremely valuable. So then you can start seeing trends. If we start seeing an area along a road where there's a continued bit of downward change, that might correspond to where cracks are starting to form, and we can look at that. The satellite data can be looked at pre and post earthquakes, pre and post major storm events, and we highly recommend it. It's the type of technology that is supposed to be used with this kind of slope monitoring application. And we highly recommend it to help us to figure out where we should best put our improvements. It's going to give us a lot more ground information to supplement the limited information we can get from just the 29 inclinometers that are throughout the Mesa. I could go in a little more detail about that, but again, that's a different situation than the slope stability. The slope stability, doing a report like what Yeh did is hundreds of thousands of dollars. It would take, it's professional geologists and engineers with many decades of expertise to sift through this data, confirm the assumptions, confirm the models, confirm the cross sections, agreed, possibly do a further exploration to confirm areas where maybe there was less data. And getting these numbers of factor of safety really aren't going to tell us anything about where we should improve the district facilities or add a dewatering well. It's just gonna tell us what really we all kind of already know from the extensive work and study that was done by Yeh and David Evans. The key to maintaining the landslide, the Big Rock Mesa landslide has already been evaluated, and the mitigation to slowing down the movement or stopping the movement is to keep the dewatering level, keep the water levels down. And so the purpose of this is not to run hundreds and hundreds of iterations of calculations to confirm those factors of safety. It's to use the best technology possible to figure out where and how we should improve the system, where there might be locations where we could even lighten some of the monitoring because there is not ground movement for many cycles, and focus in or replace a facility in areas where we are seeing a trend of ground movement.
Lori, we got 8 more.
Oh yeah, okay, sure. Hydroggers, what'd you ask about the hydroggers? I'm going to go to, I guess I'll jump to the bluff rockfall. So bluff failure, I'm not familiar exactly with what section of Benyon you're talking about there, but rockfall is really it's a gravity situation. You see it everywhere, like where they have those big chain link fences all along PCH as you're driving to and from Malibu to, like, say, Ventura County. Rockfall is just a matter of a wedge or a portion of protruding rock that is fractured and is weakened over time. And now gravity is literally, it's weakened enough where eventually it's just gonna fall. But a rock, a boulder, even a big one falling at the surface is not to affect the stability of a 140-acre landslide mass. And I would argue the same for a shallow bluff failure. That's more of an erosion situation. Not a global stability issue with the large landslide mass. I'm not sure if I got everything.
That's good. Let's go to the next speaker.
So the next speaker I have is Ed Michael. Mr. Michael, can you hear us?
Say yes.
I know. This is Don Michael. Is there any questions?
Do you have any additional questions, Mr. Michael?
Say that again, please.
I am ready to hit your timer. Are you ready to ask your questions?
I have no questions. I'm here to answer questions.
Thank you, Mr. Michael. I don't think we have any questions at this time. We will contact you or we'll ask you if we have any additional questions at this time. So, but if you don't have any next questions, if you don't have any questions to us, then let's move on to the next speaker.
Next speaker I have is Gerald Heidi. My apologies if I've mispronounced all that. Are you available? If you are, please unmute yourself.
I don't see them.
Yeah, concerning the pump on Piotr Road, and I'm concerned that the pump has not been functioning and hasn't been pumping lately, and I noticed it in my that my septic system, my seepage pit does not function because the water is that high. So somehow, I don't understand when we say the water is so low, and then I have a problem. So I think the pump hasn't been pumping lately at all. So I wonder when we're gonna have that fixed. Anybody have an answer?
Is that your only, are you finished with your question?
Yes.
Okay, all right. I just wanted to make sure because I want to make sure we get all of your questions all at once and then we can answer them. But if that's the only question, then we can move on and Lori and Nick and myself can answer them. Go ahead.
Sure. So you're talking again about the dewatering well W3 on Pedro Chica. And there is a history of perched water, especially in that area. Now, perched water is a different condition than groundwater. It's water that comes from rain, and it gets kind of trapped in the clay soils at the surface within the depths of your leach field, et cetera. The groundwater table is several hundred feet or tens of 100 feet deeper. And it's the water that's at the bottom in the groundwater table that's affecting the changes in the stability of a slide mass. And so we're concentrated on the water table down below that's sitting on top of the previous landslide surface and keeping that water level down. The well, the pump is functioning properly. We've checked it several ways when we pulled it. We not only we tested it just to make sure it was running and it's functioning just fine. The video log of the well, we took a video camera all the way down the well, and a couple things. We actually clearly saw water coming into the well through perforations at about 130 feet, which is higher than the pump elevation, but that water was just cascading straight down. And when you got down to 160 feet, just a flat surface of like you're entering a swimming pool, just a flat, the water level is certainly at 160 feet, which is where the pump is. Now, again, we're going to be putting a pressure transducer in W3 over the next rainy season, and this will hopefully add a little more data to help answer your question. Traditionally, this well is somewhat reactive to rainfall. So if we start seeing, get some big rain events and the rain starts increasing, we'll see that pump turn on and we'll bring the water right back down to the 160 feet or so. That is my answer for that.
If I can add something too.
Sure.
There's a standpipe inclinometer on Inland Lane about 100 yards from the hill. The water level in that is very consistent with the water level in W3. I think I got it at, off the top of my head, 157, which is very near the bottom of that casing about a week ago. So those two things add up. And then as far as the water level in that well, and historically always pumping, that pump's been lowered 2 or 3 times. It was originally installed at 110 feet. Water level got below that. It was lowered to 140. Water level got below that. Now it's 160, and now the water level's below that. So this is actually consistent with the behavior for that well. And that's it.
Thank you, Nick.
Yep.
Our next speaker we have is Ellen Rellis. Ms. Rellis, if you can unmute yourself. Ms. Rellis?
Ellen, are you there?
She doesn't seem to be responding to the ask to unmute.
Oh, no.
We can come back.
Got it.
Oh, you got it? Oh, there she is.
There you go.
Okay, I just did want to say it's been a very interesting listening, and actually my other questions were really answered earlier by other conversations with you, or possibly some of them in the scope of what we're talking about tonight. I can really hold on them for another type of meeting. Okay, so thank you guys for the presentation and the ongoing work.
So no questions, Ellen?
Yes, no questions.
And it's good to hear from you.
Thank you. Thank you, Rob.
Okay, we'll talk soon. You can always contact me.
Okay, thank you.
No problem.
Our next speaker is Rosemarie Idy. Miss Idy, are you available?
Okay, can you hear me?
Yes, we can hear you.
Okay, thank you. Is a purged water condition, could that be the causing of the ID of our house and also surrounding properties as well? All these septic systems on our street. How does that affect you? Because I understand we are on the lowest part of the there used to be a lake, underground water wells, and we seem to be on the lowest part of that, and that's why we do have big issues, and not only us but quite a few extra neighbors, so that has to be examined.
So I think I can get your answer, Rosemary. I think looking at the perch water conditions out there is not really within the scope, but maybe that's one of the things we add to our recommendations to actually have our consultants kind of change their scope and maybe add that to that and look at that situation. Maybe that's the cause of your concerns out there with that perch water. Perch water condition will exist when you have 2 clay layers that are underneath the ground surface and not really down below where the slide plane is for the landslide, but they're up in the upper sections of the ground. And I'm gonna wait till Lori kind of goes, gives me the gives me the crazy look because I'm
You're doing great.
okay. So but those clay layers kind of really trap in a bunch of water in there, and so what they need is areas to look and to escape and to really to drain out. And maybe that's something we can add to our list to to um, to to change their scope to look at that. Or Nick?
No, it's perch water. If we were seeing groundwater rising as a result, but we're not, and so the perch water seems to be contained within that upper zone, and there are other ways to possibly drain it to relieve that water in the yards, but it's not directly related to the stability of the landslide.
Okay. Next, is ready?
Sorry, I muted myself. Our next speaker is Ms. Georgia Goldfarb. Georgia, are you there? And can you please unmute yourself?
Sorry, I submitted the questions previously and you answered them as they were mostly about development, but I understand that's for another time.
Yeah, yeah, you're more than, at the council meeting on the 12th, please bring those up and let the council know those concerns. And let's see if we can get you an answer through that way. Just this forum here, we're really just kind of giving an update and information about the dewatering system. But yeah, please just send those questions to them or to actually even be at that meeting and raise those questions. I mean, those are good questions, and let's let the council kind of give you some feedback.
Great, thanks very much.
Okay.
Our next speaker is Colin Drummond. Mr. Drummond, are you available?
Yes, hi, thank you. Okay, I guess just the first, I've got a few questions, but just an observation is, I understand the mandate is to dewater the hill, but I would just argue that the purpose of this is not to water the hill, it's actually to ensure the stability of the hill. And we just keep hearing how we can't financially feasibly get regular answers to the stability of the hill. So I'm just confused, and I'm confused that we're talking about how great the dewatering system seems to be doing, and yet there's a long list of things that could be done to improve. So I guess it's just a statement, first of all, that I just don't feel like we're doing what we're supposed to be doing. I think it's great that water's coming out of the hill, but we still haven't heard anything about the stability of the hill. So I don't feel any better. As great a job as you guys, I think, have done with the equipment, it doesn't make me feel any better. Some specific questions. What the cost would be for this satellite study? You may have mentioned it, and if I missed it, I'm sorry. Are we going to get the report in writing? And then another question, we're just looking at the water consumption in 2019. We pumped an average of 41,800 gallons per day when water consumption was 144,000, which is almost twice as what it was in 1998. So how can we be more stable than in 1998 when there's so much movement back according to Big N? And then can we get do you have a response to Edie Michael's claims? As you know, Edie Michael was the person who correctly predicted the landslide in the first place and designed and implemented the dewatering system in the first place. He has concerns about cracking and movement and factor of safety. Are we going to actually get a response on the stability of the hill? Thank you.
So let me just kind of jump in real quick on the stability. I understand your concern and question about the stability. It's just that function of the landslide assessment district is not included in their scope. And it doesn't mean they can't do it or it can't be done. It's just not within the scope. And so we have to legally, with the assessment district, we have to only do those items within the scope of work. We can't go outside those scope of work and do anything differently. That's against the law and proper use of funds. But you know, some of those questions you bring about for factor of safety can be addressed, and we could do that. We just need direction from council if that's the direction that that they want to send us. We have some information on effort level and figures that kind of get to that certain point, and that we'll be providing that over to council like on the 12th, and we'll be looking for their direction on what to do with that.
Rob, I think this might be a good opportunity to share those cross-section slides.
If you want, yeah.
Yeah, I'd like to share my screen again.
That's fine. You should be able to.
Yeah. Just give me 1 second. Oops. Sorry. I'll show you guys that too. So slope stability is so the dewatering has everything to do with the slope stability. The slope stability evaluations were performed. They looked at scenarios at the time of the slide moving in 1983. The previous reports looked at the conditions at that time in the early 90s, once much of the dewatering system was implemented. And they looked at the stability conditions, assuming a best case scenario of really almost like the capacity of what could be dewatered out on the Big Rock Mesa. And there are factors of safety cited in the Binyan 1992 report for all of those conditions. And you can all look those up, and I don't want to get into a lot of detail, but what I do want to show you is if the water levels are rising, it means that the full landslide mass is less stable. If we keep the dewatering levels low and well below the levels they were when the slide moved, and below the levels and within the range of what's capable by the dewatering system, then that's as stable as the slide is capable of being with the dewatering equipment out there. The improvements we're talking about are looking at some of those trends, and if there's places that we do need to add a new dewatering well or deepen a well to get more water out, then the means to identify those areas is more practically used by using a survey type method like the satellite data I'm talking about, which, by the way, the price is $18,000 will get us the last 5 years of overlying data with data collected every 12 days. And it also includes the next 12 months with data, again, collected every 12 days. And reporting will be to us, to the city, and to Yeh and Associates on a monthly basis. And we'll be able to share certain plots and information with the public. But what I wanted to show you here, these are the main cross sections that in Binyan 1992, AA, BB, CC, they're essentially slices right through at different locations through the slide mass where they looked at the geology and the dewatering level. But what I want to just point out is where our dewatering levels are now relative to these cross sections. So AA is the one furthest to the east. The dashed blue line is the estimated, this is right from Binyan, the estimated groundwater table, and this is a plot directly from Binyan. It's cross-section, geotechnical cross-section AA. In 1983, when the landslide was known to be active, the water level was modeled by Binyan here. A lot of dewatering went in, and the lighter blue line is the level that the dewatering had achieved by 1990, 91, and 92 when they published their report, and it essentially considered the slide to be dewatered enough to stop moving. Now, not all of these facilities, so these little sticks are different borings or core holes that were done for the evaluation, or different old wells at different facilities, and we don't have access to data from all of them, but we have for a lot of them. And what is highlighted in yellow here is the water levels that we obtained just in the last couple of weeks for these exact facilities that were present back in 91, and we're still monitoring them. And these red marks are showing the measured depth last week. SP11 here on the coast, 22 feet below the ground surface. It's even below the levels from 1991. Here, SP33, well below the depth to water right now is 245 feet, well below the level in 1983, and even further deeper than the level from 1990. Again, SP3, same thing. And if I don't have a measurement on here, it's not because it's because the data is not available. Current data, we either the well or the standpipe is no longer in use, or for some reason or other, we're not able to access it in a way to be able to measure, get a static groundwater level from it. And I did this with all 5 of these cross sections. Cross section B, a little further to the east. We measured these 3 wells, and as you can see here, again, the dash blue is the assumed groundwater level, kind of around the time or above when the slide moved. The blue line, the light blue line, let's see, in all these ones that we've measured just last week, we're 168 feet below, 162, 162, 125. We're well below the 1983 groundwater level, and in some cases we're a little up, but we're generally right in or below the deeper one. Here in CC, it's kind of in the center, and what I want to point out here, we have a point here that's, again, well below the 1983. It's very close to the 1991. The stuff along the coast appears to be below. We have 10 and 20 foot depths at SP12 and SP13 showing below those historic water levels. And right here, I just want to, these appear a little high, but this is what dewatering well BYA1, which has been off for several months. And just last week, the well was put back in, and only after the pump being back in for a few days, the water level was at 133 feet, again, well below the 1983 levels. But the pump at this well is 250 feet. And if you measure 250, it brings us to about here. So presumably, and we'll keep an eye on this, is the water level at this location, now that we have the pump back in and it's operating through the winter, will continue to lower this level. Here, SP16 is one of the standpipes that we mentioned earlier in the presentation as having a reaction from operation of BYA1. You can see how close in water level they are. So we are expecting that as BYA1 continues to operate and pull water, that both of these will go down. And I will just remind you that this is also the core location and where we want to replacing and deepening BYA1 as our number 1 capital improvement. And so that is where we would potentially replace a well somewhere in this vicinity, and it's potentially to get all the way down, potentially even to here. Here's a good example. This is cross-section DD, a little bit further to the west yet. In this case, we're seeing all of the locations that we're able to get a recent water level on, again, just in the last week or so. all of them are below even the 1991 levels. And also with EE. So this is a metric that it really helps us to see. It's not about the number factor of safety. It's about maintaining these dewatering levels as low as the system is capable of getting them. And that's how I wanted to answer that question.
Our next speaker will be Norm Haney. Mr. Haney, are you still there? Norm?
Unmute. Okay. Now you can hear me.
All right, I'm gonna start your timer, Mr. Haney.
All right. Thank you very much.
You're welcome.
First of all, I'm very impressed with the amount of work that Yeh and Associates have been able to accomplish in the last 3 months. It's very exciting, and I want to thank you for all of your work. I have two questions here. It seems to me like that much of the driving force in this landslide has to do with the weight of the water and the cell pressure caused by the water. And so lowering the level of water, reducing the pressure, reducing the driving force, should indicate that the slide is as stable or stabler than it has ever been. So that's a question. I'd like you to opine on that. And second, I am concerned about the bacteria levels coming out of the hydroggers. I don't know about the pumps, but I read a report and it indicated that the bacteria levels were higher than what is approved by the Regional Water Quality Control Board. So the first question with regard to the driving force of the slide and the stability of the slide being significantly reduced as a result of many of your testing being lower than the 1991. And then I don't know if you can discuss the bacteria levels and what we might be able to do about it. Thank you very much.
Yeah, I'll first address your sort of stability question, and I think you have a good sense of how the groundwater level affects stability. But what I've tried to demonstrate with my cross sections is that we're well below the highest, that high dash 1983 level. That water level is presumed to kind of coincide with water levels there and above that would be high enough that would activate the slide. And in 1991, the levels were dewatered to an extent that, according to Yeh and Associates, the slide had ceased moving, actively moving. So what we're showing is that the water levels are, yeah, in line with that time in history in the early 90s. Yeah, that's how I want to answer that. The bacteria levels, yeah, from hydroggers. So I'm presuming you're looking at, so our NPDES permit has, the current permit is a little, I know some history of the previous, there's been a new order that's come out by the Regional Water Quality Control Board, and the sampling procedure from the different dewatering facilities has changed slightly over the last year than it had been prior. But in the years prior to 2018, the permit required that water would be collected from 9 discharge points along the ocean. Now those discharge points by the time the water got to them, it was the groupings of hydroggers and dewatering well water that converged and it went into the storm drain. So not only was it water coming straight out of the dewatering, but it was also melding with surface water and commingling all the way down to the storm drain system. And that, I believe, is where we're maybe seeing those higher levels of bacteria in the water quality sampling. With the newer sampling procedure, we're going around and individually taking water directly from the facilities. And it hasn't been very long, but from the data we've seen from Fugro's last report and just from the few months, we are not seeing bacteria levels from the hydroggers.
Lori, is that all of it?
Yeah, unless Nick, do you have anything you want to add to any of that?
Nick will be back shortly.
Oh, yeah, no, I think we got it. Yeah, I believe was where your question was coming from, and I hope that helped answer. So yes, I'm done with that question.
I believe we have one more speaker. However, we don't see him in the meeting. I'm still going to call the name just to make sure we didn't miss the speaker under another name. So the last speaker we have is Hack Wan. Hack Wan, Mr. Wan, if you're here, can you please unmute yourself? I believe he's left the meeting.
I see him. And
Yeah, can you, I think Terry Davis has her hand up if we don't have any further questions. If you can give an opportunity to speak.
oh, look at, yeah.
Can you hear me?
Yes.
Well, first of all, I'd like to really thank Rob and Arthur and Lori and Nick for a wonderful presentation. Lori, Nick, it's been a very, very thorough presentation, and I would like to request for us perhaps a copy of the presentation. I was clicking and doing, pictures of all the slides, but I'm sure that you can give us a better one. I do have a bunch of questions actually, but I don't think they need to be responded to right now. I will tell you what my questions are, but I would like to request that prior to the city council meeting that Rob, Arthur, Lori, Nick meet with the dewatering committee in Big Rock, and that we could possibly discuss some of the options that were discussed in the presentation, and so that we might have some input in what the priorities might be that you bring to city council. That seem fair?
No, I think that's a really good idea. So let's do that.
All right, we'll plan that.
And also just respond back. We'll send you a copy of the presentation, and a copy of the presentation will be placed on our website, where all the other Big Rock landslide documents are stored too. So that will be on there too.
Great.
So absolutely.
So thank you, Rob. So I'd just like to put out a couple of my things that came up for me during the presentation. And a lot of it had to do with the possibilities and options moving forward in terms of the tiers, Lori. And tier A, what would that add in additional costs in total to our assessment district? Again, I'm not asking you for this answer right now, but there were a whole lot of possibilities there. And ultimately, what are we talking about dollars wise there?
So I think Terry, I think we have that information. Maybe we can go into more detail and get some more feedback from the group during our breakout session.
Exactly. That's what I'm suggesting, Rob. But I just want to the questions out there so that everybody who's on the call knows what's in my head anyway. Tier C, you talk about a one-time cost for the headscarf. Is that repair and bringing it up to functionality? So, I mean, again, moving forward. E, you talked about the savings in, as you referred to, the human swap. So again, I don't have the slide in front of me, so I can't tell you exactly what it is, but that's what came up, you know, in terms of the cost per this action, and, you know, what is the savings ultimately in terms of the human, which we've talked about before, Rob, you know, in terms of updating technology and saving on, you know, hands-on. So I'd like to know more about that. And then the assessment district, again, which we've talked about over and over, is this, if we do add on to it, are we talking about having to start from scratch? Or can we add on to what we already have? And I don't think we ever got a, or maybe I don't want to accept it in terms of having to start from scratch. And I think we just, did we lose everything? You know, can we add on and not start from scratch? That's it. We got cut off.
Yeah. So assessment district. I did talk to our bond counsel, and he recommended starting a brand new assessment district, but we can, you know, so we would have to do a whole new brand one. It's not a matter of just amending it and doing it. That's what he recommended, a brand new one. But what we can do if we go that route is put language in the assessment district documents that if the new district does not pass, the old one doesn't go away. The only way that the old one goes away if the new one passes. And so that will be in there. And I think there was something else. Like, Terry, was there something else that I missed?
Mute. No, if you can hear me, I think that covers everything. I just, you know, A, C, E, A, D, all of it, you know, let's make a plan to have a meeting before City Council.
Sounds good.
Okay, thank you very much. Thank you, all of you. It was wonderful.
And I think Colin had his hand up.
I had Joe's hand up.
Oh, was it Joe?
Yes.
Okay.
Hi.
Hey.
Was Yeh and Associate supposed to respond to Edie Michael's report, or can I ask Edie Michael what he thinks of the presentation and regarding the stability of Big Rock, and like, can he use his 3 minutes to answer my question?
So at this point, I think Lori gave an overview on her response to the Edie Michael's reports as it relates to the assessment district, as in regards to slope stability and all that stuff. It's once again, that's not in her scope of work to look at and to review and provide that documentation. She's providing a response related to the assessment district.
So can he respond to the dewatering equipment? Like the presentation?
If he likes to. We're going over time a little bit, so I'll if that's the last question kind of going through, I'll be happy to do that.
Yeah, I'd love for Don Michael to give his response to the dewatering system and what he thinks of is going on.
Okay, the host. Well,
unmute you. Okay, go ahead.
Am I on now, somebody? This is Don Michael. Hello.
Go ahead.
The presentation is I find misleading. And I intend to submit a series of statements to Big Rock Mesa people as a result of this particular hearing, which I find basically misleading. The only question I have for Yeh Associates is whether or not all of these water levels that they've measured are static or equilibrium levels rather than recovery levels. Unless that's specified, their observations are pretty much meaningless from a hydraulic point of view. To get an accurate idea of what the groundwater level is in Big Rock Mesa, the levels have to be static. There has to be a period during which there's been no pumping. And I don't expect that has been done. If it has, it's certainly news to me. Again, I intend to submit a written document to the Big Rock Mesa people, which I hope will clarify what I've just said. Thank you.
Laura, you want to go ahead? Or Nick, you want to go ahead?
Yeah, I wish I would have written something down. I had a response on my, yeah, the water levels. So we talked about how we had the pumps off for at least 24 hours. And so all of those were, could have been longer, I suppose. But the other point that we made, so we did measure several water levels at those depths with pumps off. But we also demonstrated that there are several standpipes, and there are a lot of standpipes around the mesa that are further enough away from the dewatering wells that they're not influenced by the dewatering wells, yet the water levels in those standpipes are low and are considered a static water level. And we will also be putting in the pressure transducers in some of the locations where where the water level data has not always been consistent in years past, and that will help us iron out to confirm those levels and see the trends. Nick, is there something you'd like to add to that?
Pump has been down at W3 for, the water level's been static at that elevation for months and months. We didn't have to turn any well off. So that water level certainly should be accurate. I think what he's asking is that he wants to turn off all the wells and all the mesa for a long period of time and then do an entire water level elevation after some period of time where those wells are off, which we could do once a year. I don't think these water levels are invalid, especially considering how compartmentalized the mesa is. And these little areas don't necessarily all, like if we turn off, a well in the Eastern Mesa is not going to affect, SP 28. So, yeah, I would disagree that
in a different part of the slide.
Yeah. So shutting off wells in these compartmentalized subsections of the slide that are not hydraulically connected to other parts of the slide is essentially getting a static water level in that area.
Is there any more questions? Does anybody have any more questions? I see Stu, and it's really good to see Stu. Stu, do you got any questions or anything? Oh, there you go.
Oh, I guess you can't hear me.
Yeah, I can hear you now.
Yeah, I thought it was a great presentation.
Okay.
I really want to thank you all for this. Did a great job. I'm impressed.
Oh, thanks. And it's really good seeing you.
Thank you, Rob.
Okay. And if anybody has any more further questions, you can reach myself, email me, or you can give me a call, and I'll be happy to get some answers to you. And we will be contacting Terry to set up a separate meeting to go over some of those options and those recommendations to kind of get a better handle on what the community really wants to move forward with those recommendations, or if all. And so it'd be good to get some feedback before our October 12th meeting. So with that, good to hear from everybody, and thanks everybody for attending.
Rob.
Thank you. Thanks everybody for your time.
Thank you, everybody.